Why waste time in commute and spend a lot of money for NEET UG coaching? Parents, do you want your kids to achieve top scores in NEET? India's leading online NEET coaching, 100% success. NEET UG. TeenEinstein.com. At TeenEinstein, we focus on NEET coaching from Class 6 to Class 12. We think you'll like it. Our teachers are mostly PhDs in physics, maths, chemistry, botany and zoology with lots of years of teaching experience for Class 6 to Class 12. Thousands of videos, quiz, MCQs. We provide a daily worksheet of 30 questions on each topic: math, physics, chemistry and biology for rigorous practice, concept understanding, evaluation, quizzes and thousands of videos. Limited offer, 40,000 per year. Book your class. TeenEinstein.com. Contact 99402 49720.
Hello students, welcome to the POIQ discussions on JEE Advanced papers. Here I have got a problem from JEE Advanced paper 1 2022. The question says, a solid sphere of mass 1 kg and radius 1 meter rolls without slipping on a fixed inclined plane with an angle of inclination theta is equal to 30 degree from the horizontal. Two forces of magnitude 1 Newton each parallel to the inclined plane act on the sphere, both at distance r is equal to 0.5 meter from the center of the sphere as shown in the figure. So you can see this is the inclined plane and this plane is inclined at an angle theta which is 30 degree from the horizontal, and this sphere is acted upon by two parallel forces. Each one has magnitude 1 Newton and these forces are also parallel to the inclined plane, and the forces are acting on the sphere at r distance from the center. On both sides you can see this r is given as 0.5 meter. And what is the radius of the sphere? If I say that is capital R, that is given as 1 meter. The acceleration of the sphere down the plane is dash meter per second square. That means you have to find out the acceleration of the sphere down the inclined plane. Okay. So how do you solve this problem? To solve this problem, this point is very important. Rolling without slipping. So this is rotating as well as moving down the inclined plane. So if we closely look, then we can see there are few forces which are acting on the sphere in addition to these two parallel forces. I say anti-parallel forces on the sphere. So what are those forces? It is not slipping, right? I mean to say it is rotating and translating down the inclined plane. So that is called actually rolling. So when this condition is given, rolling without slipping, I can write the torque at this point of contact, the point which is in contact with the inclined plane. At this particular point, the torque on the sphere can be written as tau A is equal to I alpha. Okay. So what is this alpha? Alpha is angular acceleration, and what is I? I is the moment of inertia of the sphere about an axis which is tangential to the sphere, okay, and parallel to the diameter of the sphere, okay. So this condition we can easily write. So we have to now see what are the torques acting at this particular point on this sphere, or about this particular point on this sphere. So what is my aim now? To find out the torque acting on this sphere about an axis passing through this A point, because the sphere is rotating about the point of contact, okay, or axis passing through the point of contact. So that is why we have to find out the torques acting on the sphere, okay, because that is the cause of the rotation of the sphere, okay. So now we have been given two forces, so this will see we can find out the torques due to these two forces. So what else is acting on this sphere? There could be friction, which will be acting just upward, and see the weight of the sphere will be acting like this, and if this is the normal to the plane of inclination, then this angle will also be theta. So this side it will be mg cos of theta, and there will be a force acting parallel to the inclined plane, that will be mg sine of theta, okay. Actually this force, see this, if this is the center of mass, this mg sine theta will be acting parallel to the inclined plane through the center of mass, because the weight will be always passing through the center of mass, or center of gravity I can say, since it is a symmetric body, center of gravity and center of mass I am taking at the same place. Alright, now see this mg cos theta will be cancelled out by the normal force offered by the inclined plane. So see this frictional force mg cos theta, they are actually passing through the point A itself. Therefore I cannot get any torque due to these three forces, okay. I'll not get any torque due to these forces. I'll get torque due to this mg sine theta, this force. I'll get torque due to 1 Newton each, which are acting at different places of the sphere from the center. So look now, the total torque acting on this body I'll calculate, okay. This I'll erase for my convenience so that it will be little bit clean, okay. So this is the point A, which is point of rotation, or you can say the axis of rotation passes through this point. So I have to calculate the torque due to these forces from this to this, okay. So the first force, you look, this is actually acting here, okay. So if this is total 1 meter radius and this is 0.5, so this also will be 0.5. So I can write 1 into half Newton, so that will be the torque acting on this sphere about this point. And see mg sine theta, this will be acting, as I said, through the center, so I can find out the torque. So this mg sine theta also will be providing the torque such that it rotates down the inclined plane. So the torque due to this force and torque due to mg sine theta will be in the same sense. I am just adding them up So mg sine theta into r, because it will go or it will pass through the center of mass. So this is 1 meter. Look, this force is actually acting in the opposite direction to this force as well as mg sine theta. So this torque will actually produce anti-clockwise, or it will tend to rotate the sphere in the opposite direction compared to the other forces. So therefore I am taking the torque provided by this force to be negative. So 1 Newton is the force, and what is the perpendicular distance from this point to this point? So AR, this distance will be 3 by 2, okay, because this is 0.5, this is 0.5, this is also 0.5, so it will make 3 by 2 meter, okay. So this is actually my torque, the total torque here. Alright, let me just calculate it. So this will be half minus 3 by 2, and this will be, see, m is actually 1 kg, g is 10, and sine theta means sine 30, that will be half, okay. So what I am getting is, so this will be 5 and this will be minus 1. So 5 minus 1, this will give you actually 4 Newton meter, okay, 4 Newton meter, sorry, 4 Newton meter. This is the unit of torque. Now this is equal to I alpha. What is I? I have to find out moment of inertia about an axis which is passing through one edge, or it is actually becoming tangent to the sphere, and it is parallel to the diameter. So the moment of inertia will be 2 by 5 mr square. This is moment of inertia about diameter, plus mr square, okay, because this A point from the center, okay. So it will be 7 by 5 mr square, okay. M is 1 kg and this r is also 1 meter, so it will be actually 7 by 5. So now look, I have got 7 by 5 alpha is equal to the total torque that I have got is 4. So alpha will be 20 by 7. If I divide this, this will be 2.8 . So approximately 2.86. This is actually angular acceleration. Since the radius is given as 1 meter, we know A is equal to R alpha, sorry, capital R alpha, and R is 1 meter. Therefore, alpha and A will be having same magnitude as this. So this will be meter per second square. Actually here the acceleration is asked is the linear acceleration itself, okay. So this is 2.86 meter per second square. So this is the answer for this question. Thank you.
Why waste time in commute and spend a lot of money for IIT JEE coaching? Parents, do you want your kids to achieve top scores in IIT JEE? India's leading online NEET coaching 100% success IIT JEE. At TeenEinstein, we focus on IIT JEE coaching from Class 6 to Class 12. We think you'll like it. Our teachers are mostly PhDs in physics, maths, chemistry, botany, and zoology, with lots of years of teaching experience for Class 6 to Class 12. Thousands of videos, quiz, MCQs. We provide a daily worksheet of 30 questions on each topic: math, physics, chemistry, and biology, for rigorous practice, concept understanding, evaluation, quiz, and thousands of videos. Limited offer 40,000 rupees per year. Book your class. TeenEinstein.com